Having a pen pal can be life-changing. You can connect with someone over shared or unique experiences and learn a bit about a life and environment different than your own. It can even give you the opportunity to broaden your perspective about the world and your place in it. Jennifer Payne is a research scientist in antimicrobial resistance and founder of STEMpals, an initiative that connects kids with STEM professionals. Join us as we speak with Jen about her journey to microbiology, Superbugs, and how having a pen pal can create connection and change lives through a mutual love of Pokémon, being a Swifty, and STEM. I'm Michele Ong, and this is STEAM Powered. Good afternoon, Jen. Thank you so much for joining me on STEAM Powered. I'm really looking forward to speaking with you about your journey.
Oh, thank you, Michele. I've been anticipating it all day of coming down and sitting down and having this wonderful conversation with you. So thank you for inviting me along to STEAM Powered.
It is an absolute pleasure. And I'm really looking forward to continuing our chat about all the stuff that you're doing, which is absolutely amazing. But before we get into that stuff, I'd love to know what made you pursue microbiology.
Ooh, so let's grab that time machine and go back in time then. I would like a TARDIS if we ever do get them. That would be fantastic. But that's a whole other segue that we could go down. So we're going in our time machine. We're going back in time to little Jen. Little Jen, if we go back to like a 5-year-old Jen, she was like, dinosaurs. Dinosaurs are awesome. I mean, who doesn't love dinosaurs? Triceratops was the wonderful, amazing dinosaur that I just fell in love with. And back then I could tell you so many different facts and wonderful, amazing things about them. Move forward a little bit in time and then it was like space, final frontier. I want to become an astronaut. Okay, how do I become an astronaut? Right, I need to be able to do scuba diving. Okay, check, we can do that in a bit in the future. I need to go to university and probably get a PhD, and it looks like I need to be American. Okay. Oh, look, there's potential life on other planets and living in extremes. That looks intriguing. Let's see what that's about. So looking at extremophiles and understanding that, but then also this idea of, what is the unexplored frontiers, which is kind of what got me into that idea of wanting to be an astronaut. What is the final frontiers that we can actually explore? Space. But then I was like, that's going to be so hard to get into. Okay, what can I do along the way that could potentially still get me to be in space, but still do on Earth? What are the unexplored frontiers here? And if we were to go back to the 1800s, I probably would have been that adventurer that was going off and exploring the new places around the world. But instead, it was looking down a microscope and exploring this unknown new world, being the first to see something under a microscope and exploring this new life down in the microscopic world. And that's how that kind of ended up being a adventurer in the microcosmos of microbiology and understanding the interplay between microbes, our immune system, and how we can then treat those infections that might happen both in humans and plants and animals, and moving into that space. So I've become a microbiologist, but an innate immunologist, a biochemist, a drug developer, a business developer. Though you call me a microbiologist, it's one of the many hats that I end up wearing. How about you? What did you want to be when you grew up?
Oh gosh, it varied. I didn't have a fixed idea, and then it became one of those things that, the trends at the time at school. And because, television generation, It was like, right, I like comics. Can I be an illustrator? I would love to become an Imagineer. However, Disneyland is in America. Damn America. I mean, honestly, stifling so many career options over here for us, apparently. Not anymore. But back then it's like, well, Disney's going to be hard to get to. I live in Perth, one of the most isolated cities in the world. Could be a challenge geographically. Right. So, what do I like about comics? I love Superman. There's journalism in Superman. I do like journalism. Maybe I'll be a journalist. And I just kind of ping-ponged through that, through school. And then in high school, it's like, hey, computers, that's kind of cool. I can do this. Hey, I can make things like animate and program stuff. Oh, you need maths for animation. Damn, that I'm going to have to revisit that one. But we stuck with computers because still plenty of options.
So many options.
So that's where I am now, building web stuff because I like visual things too. And web lets you build a lot of visual things a lot faster, instant gratification kind of way. Whereas backend systems, it's like, yeah, you can see stuff happening, sort of, but you can't like touch it and play with it and interact with it. So web is where I kind of went, and I'm pretty pleased with that because it's got plenty of scope as well. I mean, like you said, it's like I'm a programmer, but I'm also aware of other hats, just like you. Many options.
So many options. It's great.
It is. And that's one of the very cool things because, you know, you were talking about how you wanted to do space, and then you went, okay, well, let's try going the microcosmos instead of the outer cosmos. But even then, all of the stuff that you can do is applicable in so many other areas. And that's how you've accumulated all of your additional hats, which is amazing.
So much fun.
Absolutely. So how did you get from, I want to study microbes to immune systems? That's a thing that's cool that I want to do.
Great question. It started with plants and being able to, well, if you're a plant, you're stuck in one place. You can't run away from something that's going to potentially harm you. So your immune system is slightly different to us in humans, and they have a very amazing immune system. And so I was looking at some of the proteins that are in plants that protect them from fungal infections and trying to work out their mechanism of action. So this protein, so a small molecule that's capable of killing fungus, was also capable of killing human cancer cells. Right. And specifically able to kill human cancer cells over normal healthy cells. That's intriguing. Why is that happening? A plant shouldn't be able to kill cancer cells. And okay, interesting. Let's see how this works and why this is working. And can we then apply it to protecting humans in some way, particularly like melanoma skin cancers and that sort of thing. So it ended up understanding the plant innate immunity and going, how can we then develop this and understand it, and going, oh, this could have different alignments for different areas in human health as well. And then from there going, oh, these mechanisms are kind of similar to what's also happening in humans. So plants have these protein-based defense systems. Humans also have these protein-based defense systems that have multiple different mechanisms in one molecule. So not just directly killing the microbe, but they also then can self-assemble into giant nets and then wrap up the microbe, or directly punch holes into, like, they've got all these different cool weaponry in one protein, just depending upon which angle you look at it. I'm like, ooh, can we mimic these to make new molecules and help ourselves develop new medicines to fight off infections? So it was then, these molecules are part of the human immune response. How are they working? Can we help our own body's immune response come back into the fight as well by having that understanding of the microbe and what happens to them as they develop resistance to the drugs that we use to fight? For example, my favourite microbe is Staphylococcus aureus, or MRSA, or golden staph, common for hospital-acquired infections or skin infections and that sort of thing.
And you wouldn't really, under normal circumstances, consider it a favourite.
I know! Don't you have a favourite pathogen?
I've seen some molecules which I think are very pretty. I wouldn't say I've got a favourite pathogen.
Do you have a favourite piece of code?
Ooh, that's tough. I've got unfavourite pieces of code. It's probably the same but opposite.
That makes sense. Yeah, I can see that. Yeah. But my favourite microbe, yes. I guess it's a love-hate relationship in some ways too, of I do not want to ever catch an infection with you, but also understanding you and all the amazing things that you get up to and do are pretty cool and deadly in its own right as well.
There's something beautiful about how dangerous it is.
Yes, so dangerous. I mean, it's got gold in its name.
Absolutely.
Looks like lovely little golden grapes, basically, under the microscope.
Aesthetically, very pleasing.
Yes, very much so. But this microbe, what I found nifty about it is that as it gets resistance to the drugs that we're trying to use, against it, so the antibiotics, it develops antibiotic resistance. It has this ability to hide from our immune response as well. So what I picture in my head is that it's got these little defenses against our antibiotics, and then it also puts on an invisibility cloak at the same time to then hide from our own body's immune response. So it's really decked out in weapons to hide and evade all our ways that we want to try and combat this infection. Can't use antibiotics against it. Our immune system can't fight it off. Oh, great. Now what are we going to do? So it was like, how can we then, instead of developing new drugs against it, help bring the immune system back into the fight and like level out the playing field so that the Staph aureus is no longer in its little invisibility cloak hiding away, and that we can actually take off that cloak and go, hey, immune system, look, you should probably kill this thing that's trying to do you some harm. Yeah.
That's amazing. But with all that kind of stuff, the way that we deal with vaccinations and all of the stuff that's there to help us stop getting sick, it's kind of about pattern recognition. So when it's being super stealthy about things, how do you pattern detect invisibility cloaks?
Well, one way is to go, okay, so you are now invisible. How can we make you visible? And so we can go, right, what is the cookie or the honey, that attractant that the immune system recognizes and knows, and how can we then make that part of the bacteria's response to being there? So taking away that invisibility cloak and making it no longer invisible by decorating it with something else instead, like neon lights, and going, hey, look, that Staph aureus, it's right here, eat it. And it's now decorated in Christmas lights instead. And so making it pretty, but also now very obvious that it's there.
So how does one apply Christmas lights to a virus and a pathogen?
Great question. So our microbes are different to our human cells, which means that we have these differences that we can use to our advantage to then mark up the bacteria in a different way compared to our human cells, and use that as a way of specifically targeting the microbe in the human environment, so that then the human can go, oh, look, that's not self. I should probably do something about that bit over there, as a way of looking at. So the outside coating of a bacteria is the cell wall. And so those components of the cell wall are very different to the outside of a human cell. That allows us to then target those different aspects to be able to then create something that's very visible then to the immune system that way.
Because of the way the human immune system works, even if you couldn't identify that it's there, is there a way to make it less palatable for the staph virus to want to attack you?
Yes, so if we look at like skin infections instead, so your skin surface has an amazing microbiome of its own self, so a whole repertoire of different microbes of both bacterial and fungi and bacteriophage and little mites as well that are all there having a wonderful time on that micro scale. But think of it as they each have their own little ecological niche that they're occupying. And Staph aureus is occupying one of them and has its own nutritional requirements and diet that it needs specifically to be able to live there. So if you can take away its food source or make it inhospitable for that Staph aureus, you can then kind of prevent that infection from happening or stop it from binding to the surface of the skin as well. So that's another way that the people are looking at being able to prevent infections, by getting things to bind directly to the surface and prevent it from taking hold and interacting with the surface that it's going to be involved in. So there's a few different ways that you can stop an infection from progressing by making it not quite as nice as what it could have been for Staph aureus to be living there.
That's neat. So because there are so many potential ways of approaching this problem, how does a team like yours decide what avenue you'd be taking to try and attack this issue?
So most of the new drugs in the antimicrobial space are ones that directly kill the microbe, and that develops resistance. So the microbe is able to then require more and more concentration of that drug to then kill them as they develop resistant mechanisms to them. And we know that that is what happens because it's basically an arms race that goes on between the microbe and our drugs that we're using against them. So we need something new and different way of attacking this problem. Thinking about it that way, then that kind of opens up new aspects. But then thinking about this in terms of a drug development pipeline and how do I get a drug or a new treatment strategy from bench to bedside, that means, oh, no one's done this before. The drug administrations of the FDA, TGA, the equivalents around the world don't know what to do with this because this is a new mechanism, a new different strategy. How do we then get this through the pipeline and where it's needed to prevent infection? So that is one of the other angles of thinking about this. How can we then make sure that it is going to be able to be translated into something that's usable, and what do we need to then put into place to make that translation? But then also thinking about it in terms of a One Health perspective, how is this then going to impact not just human health, but the whole environment as well? So it's a great big question that you just asked, and of how to then understand and open up that space across policy, across drug development, across the whole spectrum of One Health as well, thinking about it in that way, in a holistic way, but also then going user design experience. What does our patient want and need? How would it be used? What is the most effective way for managing these different types of infections? What do they need? What does the doctor need to be able to actually then create something that's worthwhile and useful for preventing the infection or treating the infection in the end?
Yeah. And I should have seen that coming. Because, yeah, a lot of these things, when COVID happened and we had to push through the vaccinations, and that went through at a relatively fast pace compared to a lot of other drugs getting approved and tested and out into the field. And a lot of people don't understand or don't perceive the scope of what kind of impact you are going to make by doing any kind of drug development or medical treatment. Because, yeah, as you said, you've got the user experience for both the end users as well as the practitioners who will be administering and using and researching it. All the fun stuff with policy and regulation across government and health, TGA, FDA, all that kind of stuff. And that's just a ton of paperwork.
Let alone to get it onto the Medicare rebate or drug prescription rebate as well, so that then it becomes actually usable. I mean, that's one situation here in Australia. It's a completely different, more difficult situation in the US and that sort of thing for bigger, larger markets as well. So, yes, a whole other problem that we often see with antimicrobials recently, that they end up getting to the shelf and being out there, but then the company goes under and becomes bankrupt because the long-term use and effective reimbursement is just not possible with a drug that you take for a week and you're now cured, and compared to something like a anti-cancer where you're then taking it for so long and the return on investment is there, and people then don't see antibiotics or antimicrobials as the life-saving medicine that they actually are. They've now become, it should be cheap. It should be a few dollars. What do you mean I now need to pay multiple to be able to get a medicine? And what do you mean I could then potentially die from an infection? So our mindset since discovering antibiotics and then having them as mainstream has really dramatically changed. If we just went back in time only not that long ago, 100 years, 50 years, infections were deadly. We're now starting to see that again. And so it's that rechange of that mindset around how do we effectively treat infections? How do we change that mindset of the users and the whole general population to ensure that we have long-term use to prevent deadly infections, rather than just that viral cold that you might have gotten instead and wanted the antibiotics for? Or can we just wash our hands a little bit more as well? But then can we ensure food safety, and how can we prevent the infection from happening, as well as then how can we effectively ensure that the antibiotics are there for the people that need them when they need them? Because that quick turn of an infection from being something minor to being something deadly can happen so fast. So fast.
Yes. And, this is why, when conversations like this occur, some people put out the whole, oh, big pharma trying to keep us sick kind of thing. And, yes, I'm going to use that tone. I'm sorry, it's just the way it is. But the complexity of all of this is, unless you're actually around that environment and are aware of the issues that come up in terms of drug development and deployment, as well as community education around healthcare and health management, there's just too many factors there where saying, yes, the drug companies will go under because they can't afford to keep going with this business model is just oversimplifying the problem.
Yes.
Because the reason why they go under is because of other societal issues around why it's expensive and why people have a certain attitude about the way medicines are used and deployed. And yeah, it comes down to we need options, but we also need to be able to be aware of what these options do and what the impact of the choices that we make in terms of our own healthcare and our own advocacy for our healthcare does for the rest of the supply stream.
Yes, and unfortunately that it's also a global issue and not just a single country, that we all need to join forces, pretty much like climate change, to actually have a wonderful, amazing world at the end of it that we can then treat and prevent infections and
in an affordable way.
In an
and one that is
affordable way.
sustainable for people to keep creating these cures and treatments that are effective.
And that will be there when people need them. Yes.
Yes. Good times. And this is why you've got all the hats.
Yes. The accumulation. Yes.
Absolutely. So as a research scientist, what do you do and how do all those hats apply in that role?
So as a research scientist, that can be lab work some days. Let me preface this. No one week looks exactly the same. No one day looks exactly the same either. So it's in the lab, doing hands-on lab work. It can be behind the desk, doing computer work, data analysis. It can also be writing up those lab reports, talking with SMEs, doing more of that business development type side, understanding markets and where tech could be going, writing grants, writing papers, teaching, the planning, where to next. Oh, so many different angles. Yes.
And just the scope for variety in your work is amazing because all of those aspects pull together to help inform the research as well, because you need to know what's going on in the market. You need to know what the business development side of things is in order to figure out the impact on what that's going to do to the research and all of that other stuff. That's very neat.
So I wear and do all these different things in a week. What do you see? Is there a typical week for you? What does that look like for you?
Well, that's a funny thing because I do wear multiple hats as a business owner who is a programmer and a creative, a technologist, podcaster, doing all things. I have a lot of things that I do. No one day quite looks the same, but they all look sort of the same, but in different ratios. It's, for me, running my own business, but also helping other people and my clients and talking to them about what their business needs are and talking to people in industry and getting to understand what that landscape looks like in different areas so that I can not only inform my clients about where they need to be heading for certain things, but keeping up to date with what the technologies are that can help facilitate their business and my business. And also because I'm nosy, so I love to find out about everything else that's going on as well. So it is as varied as I would like it to be, or as unvaried as I can make it.
How do you maintain your momentum and also that angle around balance there as well? How does that work for you?
Ooh, loaded question. That's tricky. So in terms of balance, that's a work in progress. I think it's always a work in progress because you want to be able to keep yourself engaged, but you also don't want to overwhelm yourself with all of the stuff that can go on. And because I'm very curious about a lot of things, it's very easy to kind of slip over that overwhelmed stage where I go, oh, so many things. I want them all at once. But yeah, it's just lots of lists and prioritization.
List and prioritization, yes, that is very helpful. Do you have any other tips on how to help manage that overwhelming, or what do I do next?
Being able to figure out what actually makes you happy, what gives you that dopamine, and making sure that you incorporate a good portion of that into the stuff that you do. And it's not just saying that I want to do the fun stuff and not do any of the non-fun stuff, because you can get dopamine from the non-fun stuff as well. I was just talking to a friend lately that apparently checklists and dopamine work hand in hand, because ticking that thing off the list gives you that boost. So it's being able to not put too many things on the list, making it achievable so that you can keep ticking things off and keeping the dopamine going, but also being able to look ahead to see what's coming as well. So you got stuff to look forward to, and you can shuffle that around in a way that allows you to get that nice steady burst of dopamine all the way through.
What are you currently looking forward to?
Ooh, so many things. I just acquired an iPad.
New tech, excellent. Yeah, new play toy.
New play toy, and it's allowing me to tinker with art, which I love and don't get a lot of in my regular day-to-day work. So making sure that I give myself regular doses of the art dopamine in between all the work dopamine. So looking forward to that, the learning and figuring out the art stuff. That's fun.
Do you have a go-to thing that you would really enjoy drawing, arting?
Ooh, I'm doing quite a bit with watercolors, but I have quite a affinity for retro art. So I'm trying to use the digital stuff to help facilitate learning more about mid-century illustration and art styles. Like, that's fun and it's cute and it's kitsch and twee. But yeah, I like the vibe.
That's going to be fun.
Yeah. So how about you? What are you looking forward to?
What am I looking forward to? I am one of the lucky people that was able to book the overland trek down in Tasmania. So next year I will be doing a 9 to 10 day hike down in Tassie, out bush, and seeing some amazing parts of Tassie.
That is very, very cool. Mm-hmm. Do you do a lot of outdoor stuff?
I do a fair bit of outdoor stuff when I have the opportunity. So I have to book it in so that I make sure that it actually happens, and that way I can look forward to it as well. Otherwise, I get bogged down too much in work and it doesn't happen. So yes, outdoor stuff needs to happen.
Absolutely. And that's a pro tip right there, scheduling in your dopamine and your recreation, because otherwise it's never going to happen. So one of the things that you were telling me about is your other cool initiative that you founded, which is STEMPals.
Yes.
Now, we've spoken about this before, but I would love for you to share what STEMPals is.
STEMpals, at its basic essence, is sparking curiosity. It is a penpal program for primary school kids where every student in the class is paired with their very own STEM professional to exchange good old-fashioned handwritten letters that are delivered digitally across the year. So it's wonderful letters, amazing drawings, so drawing on that art aspect that you're talking about, but the kids get to have this amazing experience of having someone who cares outside of the classroom write them a letter in that STEM professional space to get their understanding and sparking their curiosity in such the diverse range that you can use STEM in. And they just love the fact that they have their very own STEM professional to write to and ask all those questions of across the year.
That is so cool. So in this digital age, what gave you the idea to use mail as the medium for outreach?
COVID.
Was it a COVID project?
So Melbourne, we had some lockdowns that happened, which meant that we could not move very far. And I would often go out to schools and do talks at schools, and that was no longer able to happen. And so having some amazing friends that are also ultimate frisbee players, but also primary school teachers, and having conversations with them, we ended up starting up this penpal program where I paired up early career researchers, initially just mainly in the microbiology field, and my friends and colleagues and that sort of thing, to then write letters to their classroom of students and exchange the letters that way. And then it grew from there.
That is very, very cool. And I guess even more importantly, because everyone was sort of getting digital and virtual out at that point, being able to have this kind of tangible thing that arrives in their mail and so novel would have just been such a different experience for the young generation of kids right now.
Yeah. I mean, I don't know about you, but I don't really see any mailers and bills and advertising and that sort of thing. So an actual piece of mail that's written is pretty exciting. But for them, it's like, I don't even know what this is type situation. But unfortunately, we've lost that delivery through the mail system because fires, floods was causing absolute chaos of getting letters delivered on a timely schedule. So we've now resorted to scanning them and having a web platform that they come through. So they're still handwritten, still glorious, amazing drawings and that sort of thing happening, but they just come in a digital form so that we can then also reach so many more people that way too.
Yeah, and it's amazing because even if it is digital, you still get that very personal touch of having something that was written or something that was created. And yeah, I don't know, that's the energy behind receiving something like that is entirely different. So what are some of the experiences that have come out of having pen pals and STEM pals write to each other?
Oh, so many stories. Oh, how long do you have? Let's see. So one of the most recent ones that are happening right now are letter parties. So letter parties are an exciting time that happens in a classroom because the teacher's received all the letters and the teacher has had to deal with the fact that the students have been asking them every single day, are the letters here? Are the letters here? And they're finally here. So you then have this party atmosphere that happens. And walking into one of these classrooms, you know which classroom you're going to because you can hear it walking down the hallway. They know that the letters have come in. They know that it's happening. There's just this bubbling excitement that you hear as you're walking down the corridor to enter that room. So we're going to open that door and sit down in the back of that classroom. And I'll tell you what happens. So you've sat down in the back of the classroom. The kids are having a hard time even being able to sit still as this excitement kind of like bubbles up here and there and everywhere. They're so excited. They finally calm down enough to go, okay, we're now going to hand out the letters. And they're told that they can't open them until everyone in the classroom has their letter. This causes its own chaos because the kids go, their name gets called, they run up, get their letter, and then have to sit back down and sit there and not open it. So you can see the kids peeking in the corners, like they're trying to peek in the corner, see what's in the letter and like holding it up to the light and that sort of thing is happening.
Marshmallow experiment.
So you now have everyone in the classroom has finally received their letter. There's still all this excitement bubbling around. And then the teacher says, okay, you can open them. Letters get ripped open, paper goes everywhere. And then letters start getting read and the classroom, quiet. Not a peep, not a sound, as the kids are all sitting there reading their letter. But it doesn't last that long because then it goes, hey, look, and look, as they start sharing their letters with their friends next door to them and that sort of thing, as this excitement then bubbles and you can see it ripple around the classroom then as it happens, as they're starting to read their very own letter from their very own STEM professional that has taken the time and the care to actually write to them personally and answer their questions that they've had. So it's this really heartwarming moment and there's so much enthusiasm, so much excitement going on in the classroom at that point in time. And you are on an absolute high yourself because you feed off this excitement. And the comments that I've gotten back from teachers is like, oh my goodness, that was amazing. I am on an absolute high for the rest of the day. Getting the kids to settle down for the rest of the day has also been problematic, but it is the most enthusiasm that I've ever seen for them to write. The teacher at the end is like, the kids just want to write now. They want to write their reply. And I've never had the kids be so excited about sitting down to write anything before. So this idea of helping instill scientific literacy and that sort of thing, we're also instilling English literacy as well, that they're now having this enthusiasm to write letters, which, if you indulge me in another story, is
Of course.
one of our teachers told me the story that she was absolutely amazed with the outcome for their student. So they, at the start of the year, they've come through class and they're in grade 6 at the end of the year and they're just not really that engaged of a student. I finally get them convinced to just write a sentence, ask a question, and draw a picture.
Bare minimum.
Whew, we got that. And I let the STEM professional know that this student was much more of a visual learner. Great. And so what we ended up having was this almost like a comic book and comic strip that was being written by the STEM professional on the other end. And the student by their third letter was coming up to the teacher going, "When's the letter arriving?" And they went from barely writing that sentence, drawing a picture at the start of the year, to then sitting down and writing a full paragraph. So just this amazing change of engagement, but also then thinking about how much of the world is now going to open up to them by being able to now write and being engaged in that schooling as well, to then open up not just their STEM literacy, yeah, okay, sure, but English literacy and being able to gain those skills, those life skills, just because someone cared and it was bigger than the classroom and they could see that engagement actually happening and writing for purpose.
Yeah.
Oh, yeah.
And it's wonderful because that STEM professional was happy to entertain the visual medium. And it's all about understanding that not everyone has the same learning modes.
Yes.
And giving people choices and options to be able to learn in ways that will allow them to thrive. So this is such a great opportunity for people to explore that as well, because now they understand and they can see what it is that motivates them or what it is that engages them and pursue it. So cool.
So much fun. Oh.
So how does one get a STEMpal?
Great question. So what we have happen is that a teacher will sign up their classroom to take part in the STEMpal program. And that usually happens at the end of a year, that they then sign up their classroom for the next year. And we then recruit STEM professionals about that same sort of time, so that October, November, across into January. So we then pair up STEM professionals with the students. And we don't pair up based on science interests, which you might think, but because kids at that stage don't know what microbiology is or what computer engineering is. I'm like, okay, I like computers. Yep, cool. I like rocks. Yep, we can do that. But instead, you will pair up kids on, they love chess, they love Taylor Swift, they love Roblox, they love rock pooling, going for hikes. That sort of thing is what we pair up STEM professionals on. So what hobbies would you list, Michele, if you were to be paired up?
Art and cooking and, this is hard. Reading, we can do reading.
Yep.
But yeah, it's a good idea to do that because it's also, you don't know where an interest will lead you.
Correct. And it's also showing them that there is shared interests and that this person on the other end, despite being this STEM professional, actually shares these hobbies and interests with me, and that you can then kind of see yourself potentially in this STEM professional. And it always helps having that common interest to then fall back on. But then also you're like, well, we both enjoy cooking. Well, actually, there's some STEM involved in cooking, and you can kind of go down that line and draw in what is the hobby that they're interested in? What is the science or the STEM angle that you could then draw into that hobby to show them that actually STEM is all around them in everything that they do? It's just how you look at things and how you want to find out about things and be curious about things. And yeah, that kind of thing.
Absolutely. And so, what would your STEMpal profile look like?
Oh, great question. So there's some ultimate frisbee listed on there. There's rock climbing, there's hiking, there's reading, cooking, probably some rock pulling. Yep.
That's cool. You're going to get a diverse range of kids with that.
Yes.
That's awesome. So, what sort of age group are we looking at for the kids who are participating in the program at the moment?
So it's currently upper primary, so grade 5 and grade 6, which is those 10 to 13-year-olds. And there's actually science behind why we're picking that age group. One is that if you have a look around, there's not many science programs for that upper primary school age group, often for the high school and that sort of thing. But the science behind it is that we know that kids are already making decisions about what they don't want to do by that age. We also know that positive STEM experiences at an early age then changes your STEM engagement for the rest of your life. So we're hoping that STEMpals gives them a positive STEM experience that will then change how they engage with STEM and their scientific literacy for the rest of their life. That's the aim. That's the science behind why we're targeting that age group, to then have this lifelong change and spark that curiosity, make that change for the next generation to be more scientifically literate, because we know that their problems that they're going to be facing in the next generation is going to need that STEM. And how can we ensure that? And also, how can we ensure that I'm not hitting my head up against the wall about climate change and vaccine denial and all this wonderfulness, that if we had some scientific literacy across the board and improved that, that hopefully the next generation will not be running into as many problems that can't be solved.
It's such an absolutely perfect time for it as well, because so many other high schools will also be getting you to think about the kind of subjects you want to do. And if you're going down the university track, the kind of subjects that you should be enrolling in and choosing for your examinations. And at that age, like you said, you're still not quite sure and you still don't understand what it means. As you said, you're a microbiologist, but you're more than that. And a lot of people won't get that scope at that age until you show them what that scope looks like. And having a STEM pal who can say, well, this is what I do, but this is not all that I do, and this is not all that I am. And it humanizes it, and it gives you perspective. And as a child or as a preteen, starting to think about what their future looks like, perspective is so important. So it's such a valuable program. So what sort of people are you looking for to become a STEM pal?
Oh, maybe it's a question around what it's classified as a STEM professional and who associates themselves as being a STEM professional, because scientists, academic scientists that work in labs and that sort of thing, they easily associate themselves. Great, perfect, wonderful. But people like you, Michele, in the wonderful tech field and the tech area, and that encompasses so much, don't associate themselves as being a STEM professional. So yes, I have a problem there that the T out of STEM is not well represented. The engineers will often recognize themselves as being engineers. Excellent, great. So they're there. Mathematicians tend fewer and far between, but it's often I use maths or I use that angle in the work, so that comes out. So many people have the opportunity to be a STEM professional and therefore be a STEM pal. It's just, I guess I need to do an educational piece about who is an actual STEM professional.
Yes, absolutely. And, there are a lot of complaints at the moment. We think we're getting very political this episode. There are a lot of complaints about what is and isn't STEM. And, one of the things about STEAM powered is the fact that there is the A in STEAM. And that is for so many reasons. But the idea that people are gatekeeping what is and isn't a STEM field just seems really redundant because there's so much intersection and there's so much interdisciplinary work, and everything we do touches everything else.
Yes.
So saying that you're only one of these letters is no longer accurate. What you do covers so many things. You're not just a scientist, you're a technologist, you're also doing all the stuff to do with policy and regulation and the A part and the human part of all the work that you do. All of this is multidisciplinary. And there is not one person who is remotely STEM or STEAM who can't say that they don't touch more than one letter in any of the work that they do. And even people who aren't in the industries listed, who are coming in sideways or doing other things in the area, they still can't.
Yeah.
Because you've got a bunch of people bringing their experiences from other industries into STEM, because that's how we innovate and that's how we grow. So, yeah, there's just so much scope for who STEMpals could be if we learn that most of what we do is STEM.
I mean, I would have loved to call it STEAMpals, but it just doesn't work as well as STEMpals if we're playing on penpals.
I understand. You got to work with the puns.
Got to be puntastic. And unfortunately, STEAM did not work.
That's okay. It worked for me. So we now know who can be a recipient of a STEMpal, and we know who can be STEMpals, but how can the rest of us or the rest of the community help your initiative and help STEMpals grow?
So we want to ensure that low socioeconomic, regional, remote students have access to be able to see the diverse, amazing things that they can do with STEM and how that could then be applied into their own communities. And unfortunately, the program costs money to run. To be able to sponsor a classroom, to be able to access the program is one amazing way that people can help. Ensuring that we can give access to the program to other areas and give the opportunity to all the students to have the amazing experiences that our metropolitan people do, so that this experience is then able to be had by everyone and anyone everywhere in Australia. So far, Australia will take over the world later.
One step at a time.
Yes, one step at a time.
Yeah. Incredible. That's probably a brilliant place to wind up on this. So I've got one last question to ask you before I let you go. Given your breadth of experience and all the hats that you now wear and how you came to be in this incredible position, what advice would you give someone who'd like to do what you do, and what advice should they ignore?
There's not one path to get anywhere. It's a winding, wonderful, amazing thing that you can do. So don't feel like you're stuck in one particular path because you've done one thing. Just keep doing what you enjoy and where you find that dopamine hit. Go back to our... and keep following that as long as you can keep surviving and keep living, I guess, is the other thing. So that's the other area, to make sure that you can still cover your bases, cover your costs, while still having fun and enjoying what you're doing. Yeah, and having that impact, or at least for me, it needs to have some form of impact and be meaningful.
And that is very true. A lot of people do dismiss the fact that it's okay to do stuff that sustains you to be able to do the stuff that you thrive on. So being able to afford to keep doing the other good stuff is also an option.
Yes. And I really want to break down that silo angle of your skill set. You don't know who will actually need it and how it can be applied in a different area, and your perspective, your understanding and coming at it from a different angle could be just the ticket for solving that next problem. To have that different mindset, to have that different point of view is what causes that innovation and that next spark. So always be curious.
Fantastic. That's amazing advice. Okay, well, thank you so much, Jen, for speaking with me today. It's been absolutely wonderful hearing about your journey to not just microbiology and the amazing work that you're doing with STEMpals and just helping to seed that curiosity in the next generation. So thank you so much. It has been such an amazing conversation.
No, thanks, Michelle. And thanks for supporting our STEM community in sharing all these wonderful, amazing stories.
Yeah, it's an absolute pleasure. So thank you again, and I hope you have an amazing evening.
Thank you.
If you enjoyed this conversation, please let me know. Subscribe to this show, leave us a rating, and share this with your geeky or geek-curious friends. You can also support STEMpal on Patreon under STEMpal Show, the link for which will also be in the show notes. Thanks for tuning in, and we'll see you next time.